Good morning. Now y'all can refer to page number 4 of your textbook. In my first lecture, I said that the gravitational force is proportional to the product of the masses of the two bodies and inversely proportional to the square of the distance between the two bodies. Now, whenever I need to remove the proportionality sign, I need to introduce a constant. What is proportionality? Proportionality states that when something increases, the other factor that is related to it also increases or decreases. Directly proportional will increase and inversely proportional will decrease. So now F will be equal to G m1 m2 upon r square, where G is universal gravitational constant. Now Henry Cavendish he found out the value experimentally to be 6.673 into 10 raised to minus 11 Newton meter square kg raised to minus 2. The index minus 2 means it is inversely proportional, or it is 1 upon kg square. So the index is minus 2. Okay, this is 11. Now how do these units come? Let me get back to my original expression. F is equals to G m1 m2 upon r square. Now the unit of force is Newton. Okay, I will multiply this r square, and if I take the SI unit, then it will be meter square. Now this m1 m2, the units will be kg, so it will go in the denominator. These things will go in the denominator. It will be kg square, and when this comes on top, we represent it as minus 2. The index, when it comes in the numerator, it becomes minus 2, will be equal to G. This is just the representation of how the units come. Several bodies were taken, their masses were considered, and then the value was found out to be, the distance was also considered experimentally, and then the value was found out to be 6.673 into 10 raised to minus 11, which is a very small number. 10 raised to minus 11 is a very small number. So I hope I am clear up to this point. Also, it is given that if one object, the mass is doubled, the force doubles. Now, okay, let me take F, which is equals to G, the value remains same because it is a constant, m1 m2 upon r square. Okay, consider two bodies, m1 m2. Suppose r is the distance, okay, and the force is acting. Now what I will do, I will double up the mass of m1. So when I double up the mass of m1, I'm just representing it by a dense circle or a sphere, rough sphere. So this will become 2 times m1. because the mass is doubled. m1 is the mass of the initial, distance is the same, m2 is also the same, m2 is also the same, distance is also the same. So this force will be something change. I will represent it as F1. So now what will be F1? F1 will be G. What is M1? M1 is changed to twice. So it will be 2 times M1. M2 is the same. Distance is the same. Now take 2 outside. Okay. And just take the other terms, that is G, M1, M2 upon R square, which is equals to, see the equation 1, 2 times F. Therefore, F dash or F1 is equals to 2 times F. This is what is the meaning given in your textbook, that the force doubles when the mass of one of the object is doubled. So I hope I am clear with these two sections. The next section I will take in the next lecture. I am purposely creating short videos so that one particular concept goes in your mind, because the human brain cannot function more than 10 to 15 minutes on a particular concept.